Good morning, Good Connections listeners. In this episode, we're thrilled to have Lew Cox, the Senior Director of Business Development at XCharge North America. He's been on previously, but in this episode, it's really great to have him discuss a lot of the new things that have happened in just a short few months since we spoke with him last time. Lew brings a wealth of knowledge and experience in the electric vehicle industry, and today we'll dive deep into the transformative world of microgrids, the latest advancements in EV chargers, and the current state of the EV market. Whether you're an industry insider or just curious about the future of electric mobility, this episode is packed with insights you won't want to miss. Enjoy.
Absolutely, Chase. It's a pleasure to be back on Grid Connections. The last time we had a discussion, I think we really got into the nitty-gritty about some of the benefits that not only our products provide, but a lot of the companies in the space are working on. Just for those who are new to who I am and who XCharge is, I'm Lew Cox. I am the Senior Director of Business Development for XCharge here in North America. And XCharge is an EV charging OEM where we design and manufacture DC fast charging products kind of across the gambit, including some products that have integrated bidirectional batteries. We really thought that there, and still do believe that there is a space currently for very grid constrained areas and providing infrastructure for them to provide DC fast charging. I think if EV adoption is going to go where we all want it to go collectively, we have to attack all of the issues kind of at the same time, and that doesn't involve leaving behind those areas that are maybe a little bit more difficult to attack. So batteries help us get that done.
Yeah, I think that's what I've really enjoyed about even our last conversation. And my apologies to anyone listening if they hear a dog panting. That's a dog I'm currently watching. But I think our last conversation, we just barely scratched the surface on this topic specifically and really talked about the state of like EV charging and a lot of we're seeing in that space. And I think that's what I love about why I start this podcast is you kind of get that trifecta of like renewable energy and new just energy challenges to obviously electric vehicles and electric transportation. And then there's kind of the third component, which is actually making all these work together through the grid, obviously. And then really what we're seeing the big need is through newer and smarter grids, like what is leveraged with microgrid technology, and then obviously how energy storage plays into that, kind of making the system we have even much more efficient and ideally have a higher uptime. So with that, I'll kind of, I know you wanted to talk quite a bit about it, but like where, let's take a step back just in case. I feel like the last couple episodes have been pretty electric vehicle heavy.
Sure.
So for those who may not be as familiar with microgrids, what's a good way for people to think about how that is different from the current American grid here in North America?
Yeah, I mean, in its simplest terms, right? When we talk about a microgrid, what that is a localized community of not only generation, but storage and distribution that doesn't, rely solely on connection to a larger generation source further away from where you're using the energy. The concept behind why a microgrid makes sense is that you can take a small community or a series of buildings or even a specific property almost entirely to self-sufficiency through the use of distributed energy resources. And when we say that, we talk about things like battery support. We talk about generation on site, like solar installations, and a combination of those things will allow you to remove what otherwise would be a load on the grid, in what could be a grid constrained area, and localize their usage and their generation and distribution to one specific subset of properties or types of infrastructure, which typically makes it more scalable for what you want to do in the future without having to rely on the utility company so heavily.
I think one, that was an awesome summary of microgrids. But two, I think one of the things you mentioned there is a really great point that I think a lot of people, it seems like some people, when you start talking about microgrids, might just know enough to be dangerous.
Right.
And so they think that microgrids means that it's kind of its own removed, kind of off the grid completely. And can it be? Yes.
Sure.
But the idea is actually that it's working in kind of in tandem with the power grid, and ideally improving it and making it a more resilient resource for everyone. So
yeah, I think it's really important what you said there, in that while it can be totally self-sufficient and not take anything from the greater grid, I think the more appropriate use of a microgrid is to provide support to neighboring properties, to the grid itself, And in order to do that, right, I mean, if you can take your load almost entirely off of what you're relying on from the utility, and then you have excess, when the utility needs it, being able to provide that excess bidirectionally to your neighbors, to your neighborhood, to, the utility itself in the event of a demand response sort of situation, those are all very helpful. And I think the utilities more recently have gotten really on board with supporting initiatives that help provide them with the more resiliency that they're looking for during the electrification of the United States.
For sure. And I think it's a really cool thing that there's obviously a lot of politics that kind of involve and kind of maybe misperceptions in the space. But I've always thought that there's kind of two really cool things that microgrids really help unlock. And one is redundancy, should there be a blackout or something. But also then kind of that resiliency factor and being kind of a net positive. And then almost kind of flipping around and becoming a very strong business case for that microgrid, especially if, like in the example you just talked about, like a small housing community possibly having their own microgrid that, depending on how it's set up, you can even sell that excess energy back and find some really great win-win scenarios for a lot of different use cases.
Absolutely.
So I know one of the things you kind of wanted to talk about was on the kind of status of microgrids. Like, in your exposure at XCharge, like what have you, because, and my apologies, how long have you been now with the company?
So I've been with XCharge both as a consultant and then now a full-time employee for the better part of 2 years.
Okay.
My prior role, I was at a large EPC, or engineering, procurement, and construction company, where we did a lot of design, engineering, and construction for all kinds of public infrastructure, be that, cellular telecommunications, satellite earth station, power substation where necessary, as well as EV charging infrastructure. And over the last 4 years, I've moved specifically into EV charging, and then I was consulting with XCharge as they were migrating their business from Europe to the North American market. And then it made sense, about a better part of a year ago to bring me on full time and head up business development for them here.
Well, that's great. I that's what I thought it was a couple of years. I just wanted to double check, but I'd be kind of curious. I've definitely heard a lot of things as to where the status of microgrids were during COVID and before COVID. I would be just kind of curious to hear, like, and probably good maybe background information for like listeners, like the last 2 years you've been doing this, like where have you seen the changes and kind of the opportunities in that space? And maybe then we can kind of, after we've discussed that, then start looking like forward of some of the potential that's being unlocked by microgrids.
Absolutely. I think when we talk about microgrids and the growth and popularity for them, we have to talk about the price of batteries, right? Because
for sure,
battery technology is essential to the microgrid creation and removing that peak load off of certain properties, off of certain, high demand resources like EV chargers, where you can quadruple or maybe even 10x the amount of power coming out of a property that wasn't designed for that originally. A microgrid or a battery solution helps really smooth that out. But a couple of years ago, thinking back to 2020 when I was in the space, right, and we were working on infrastructure projects, most people I talked to were saying that's so far in the future. Batteries are cost prohibitive. It's really not scalable. What are we going to do with the batteries when they're dead? And then very rapidly over the last 4 years, we've gotten much smarter about, the cell costs. And I'm sure you've seen the charts online where it's like exponentially less expensive,
I mean, it was crazy because it was starting to go down, then went exponentially more expensive because of COVID and supply things. Now we're for multiple reasons, but a big part is supply. We're now seeing it really go down, which I think if you're in that space, it can be a little scary. But I think for others, I think just for microgrids and a lot of those reliant technologies in general, this is a huge step forward that's really kind of helping accelerate this. And I think just one thing that it's kind of been needed to happen and will help kind of let that industry in some ways even out a bit and also mature.
Innovation in general typically drives efficiencies and costs, and you're starting to see that with microgrids and battery technology, where it's now much more accessible for types of projects and folks who maybe aren't the utility directly, right, to start to provide these resources to the projects they're working on, to start to think about load management in a more intelligent way than just make a 7 megawatt request from the utility and wait for the right transformer. Now you can dramatically speed up a project and increase its profitability if you have the right kind of solution designed from a battery and a bidirectional microgrid perspective, and especially if you take advantage of some of the rebates that are offered through the federal government, not only for the batteries, but for any sort of generation via solar.
Yeah, and I think we've talked about EVs, and it just kind of shook free of my mind by you saying like the experiences with microgrids and what people were thinking just a couple of years ago about like, oh, these are so far out. And well, one of that technologies, I don't think it's matured as quickly as microgrids have, is kind of like vehicle to grid or
Sure.
vehicle to X technologies. And we're starting to see some of that develop and good, and some of it shake out that it still might be a little ways away. But I'm curious if there's been any. I know we've talked about vehicle to grid potential a lot on this podcast. I'm just curious if that's something you've been having more conversations about lately in your own discussions.
We certainly have. I think where the most use from a V to X or a vehicle to grid use case comes into play is when you talk about fleet vehicles that are parked, for long periods of time after they complete their routes. These could be last mile delivery vehicles. These could be a series of school buses. There are several companies in the space that focus on that bidirectional AC level 2 charging, where you can tap into these vehicles substantially larger battery than commercial or than passenger vehicles, right? And you can use that energy to not only offset, the charging of other vehicles, but potentially even offset the entire utility bill for getting them up and running in the first place. If you can get battery connected resources, interacting in a way with the utility that helps them out in a demand event, it can be a very profitable adventure. And I think if we're talking about electrifying every vehicle in the country, at some point, it's probably a necessary venture, right? To be able to use those batteries as resources more than as strains on our grid.
No, that's a great point. Kind of going back to microgrid specifically, where are you seeing the most, I guess, the interest, or like when people, because with vehicle to grid, I think it was always, just to use this kind of an example, people kind of got the idea quickly, like, oh, that's a cool use case.
Right.
But then the practicality of it and like the execution of it became a lot more complicated. Whereas I think in some ways, microgrids are almost the opposite. It's like, why would it make it more centralized? Why is that a good thing?
Sure.
But then when you start like actually looking about the technology and what we need to do, a lot of it's already there. Whereas vehicle to grid, it's kind of, you need the right charger, you need the right vehicle, you need the right software, all this stuff. Whereas the others, it's still new, but a lot of it's already there, kind of, and something you can kind of take off the shelf a lot easier.
Sure. And I think when you're the utility and you're looking at various projects that are coming through your development pipeline, when you have a dedicated distributed energy resource, that's a lot more attractive to you because you can depend on that, right?
Yeah.
You can depend on it. You can pull energy from it much more quickly. You can have a 1-hour system dump several megawatts, whereas in a vehicle to grid situation, you're limited by the capacity of the charger that it's plugged into, which could be, 11 kilowatt from a bidirectionality perspective.
On a high one. Some are less.
On a really fast one. Yeah. Some are even slower at 7 or lower. So you would need hundreds of them at the same time in order to get any tangible value as a utility company. So what we have seen, at least in our space recently, is projects that have these dedicated distributed energy resources or batteries or microgrids, et cetera. They're getting prioritized by the utility because it's not, creating demand, it's solving a problem for them. And that allows them to serve more of their customers more efficiently by not having to dedicate a transformer to this project that otherwise could go without it, right? Specifically related to DC fast charging.
I'm kind of curious. I mean, you mentioned you live in San Diego. Like, if I'm listening to this and I live in a larger city like a San Diego, and what might be an example of a microgrid implementation that like a utility would be doing in a larger city right now that I could see if either I could become a part of or something that might actually impact me on a day-to-day basis, for example?
Yeah, I think what's a really fun use case is we have a project in development right now in downtown San Diego near the airport where there is a donut store, with a drive-through that doesn't have a huge load, and it's in a very condensed, older infrastructure type of neighborhood where bringing in new 3-phase 480 power is extremely cost prohibitive. So we looked at all the various methods on how to electrify this parking lot because of its location. Yeah. And when we got down to it, our net zero series products, the bidirectional, grid forming batteries, allows us not only to take the entire load of that donut shop off of the grid, right? But we get to skip what would otherwise be new line drops and several hundred feet of run from the point of connection for the utility for SDG&E.
Yeah.
And that's a project where, sure, it's a very small microgrid and we're helping a donut store, right? But we're also providing DC fast charging to the neighborhood without dramatically stressing out SDG&E in the process or waiting 2.5 years in order to get the right infrastructure to make that project happen. So that's an example, a real world example that I'm working on right now where using batteries, using intelligent infrastructure or distributed energy resources allows us to speed up the process, help out the utility, and moving forward, that donut shop no longer pulls from the grid, during peak times because we have that bidirectionality incorporated into our design.
No, that's great. I feel like that was completely incidental or like kind of unintentional, that example, but I don't think I could have teed you more up for that. That's great. With that, I guess, there's been talk about it, and I think especially as someone who's been dealing a lot more with the EV charging space, like one of the big things right now is like permitting and getting transformers. Yeah. It's really all of this stuff before any shovels. It's all of that stuff that takes a lot longer. Right. Can you share a bit about how, obviously like the reduction of transformers and some of these upgrades, but are there any other things that kind of help make a microgrid solution a better and kind of faster project for people who might be listening to think about like, oh, maybe I should approach it this way instead of doing the more kind of traditional way with a project they might be working on, or areas in addition where it saves time in that process?
I think saving time in general comes from not needing some of this extremely limited infrastructure that we're talking about, 2,000 kVA transformers, switchgear. There's such a switchgear shortage in the country right now that many companies have resulted to alternatives like H-frames, where you just bolt on the exact same components, get that certified, at the field level by the utility, and then use that instead of a switchgear. Not as clean, not as neat, but it speeds up the project. I think when you start to look at using batteries to bridge some of that and then connect directly into house power, which otherwise would not be possible to power multiple DC fast chargers. Right. You're using the existing infrastructure as it is, and then not only, kind of skipping the line for waiting for all that additional equipment, but you're taking that load, like we talked about in the donut shop example, we're taking that load off of the grid moving forward so that those resources can be redirected to places that need it by the utility.
And that's pretty cool. And especially in this example where I've had people who kind of listen to the podcast kind of reach out to me, and they may be new to the whole idea of EV charging, but they think it's kind of a cool thing. It's like, I own a building, I have this, what can I do to like actually do it? And then they start looking into logistics and the cost of it. And it kind of understandably sometimes scares them off.
Sure.
Whereas like this is a great example of kind of a project that speeds it up, brings down a lot of the costs, and still makes it a very feasible operation for both the business and then the addition of adding charging to the location.
Yeah, what I think is also really important to focus on, and what we focus on at XCharge, not only internally with our deployments, but with our partners, is that EV charging needs to be a profitable adventure, without tons of subsidies, without waiting a decade to get an ROI. And in order to do that, you've got to find a way to get the most amount of margin you can per kilowatt hour that you're trading, right? Because all we're doing is essentially we're selling kilowatt hours to vehicles with our technology, right? And depending on when a vehicle is plugged in, and we know through, untold amounts of data points that most people are charging between 4 in the afternoon and 9 p.m. That's considered peak. Most people are doing most things that involve the grid between 4 and 9 p.m. Right. So if during that time your utility rate is twice as much as it is at midnight, you're substantially less profitable in the time where you're dispensing the most energy possible. So if you use batteries and you can schedule when you want to fill those batteries, like during super off peak of midnight to 4 a.m., and then during those peak times when you start to get hit, you're selling energy that you paid substantially less for, sometimes half for, right? And you're still able to service the customer. You're more profitable in the distribution of this energy, and then it gets you much more quickly to ROI, which actually starts to make EV charging investable. Some of the most sophisticated investors in the space right now look at EV charging at scale and say, it's a little too risky, there's utilization risk, and it's too expensive from the utility. When you introduce alternative distributed resources like batteries, you can start to solve some of those objections, at its core. And it just takes time in order for you to get the adoption that you need to make this a very profitable adventure and make it investable.
Yeah, and I think there's definitely a couple different parts of this. We're talking about the batteries in this case, but also then there's the actual charging infrastructure.
Right.
And I think there's some really cool products that your team has been actually delivering. One of them is the North American Charging Standard. I want to say it's a 200 kilowatt model that Kyle Connor, actually, who we've had on the show, is technically like demoing at his place in Boulder, or not in Boulder, but
at Colorado State.
Yeah, and I'm trying. It's not. I always want to call it Fort Worth. It's Fort
Collins.
Fort Collins, correct. Yeah. And I think that's just awesome to see that. And so I'm kind of curious. Can you tell us more about that product and kind of the interest in that? Because obviously, there's been a lot of headlines about the North American charging, and that's a whole different thing. We can talk about that too. But obviously, that's where a lot of automakers are going towards that standard, and they're kind of looking for options out there in the space for effective EV charging. And so, yeah, I'd just love to learn a little bit more about how that's been going and some of the projects or kind of ideas that have been unlocked with this new product.
Yeah, I think at XCharge, we focus primarily on the driver, right? We want to make sure that if you pull up to an XCharge station, no matter what vehicle you've got, you should be able to take energy if you really need it, right? And we started deploying the North American Charging Standard before it was even certified by the SAE for J3400 back in March of last year. And the reason we did that and went through the UL certifications to get that done was to selfishly prove that we could charge Teslas as well as CCS vehicles. And then about 2 months later, after we had already secured our supply chain, the entire industry decided to adopt the standard, and within a week. I mean, I think you remember that time. It was a bit madness when it happened. And we just so happened to be sitting on already fully integrated, publicly deployed infrastructure with the North American Charging Standard on it. The first one we deployed, the first two we deployed were at a facility for MD7 in Dallas, Texas, and then another one for a C-store owner in Harahan, Louisiana. Both of those had Tesla plugs on them natively, and we deployed those as the first in the country from an OEM that is not named Tesla outside of ChargePoint, right? So ChargePoint was a couple of days behind us, and they did it at their testing facility. We deployed these to customers in March. Right. So we were really proud of that, and we got a shout out on LinkedIn from PlugShare because we had the first check-in on the North American Charging Standard, and we celebrated a little bit as a team, but it also reminded us that, okay, we really do have to continue to look ahead of the curve and continue to innovate to be more effective with the technologies that we bring to the market. And the unit we sent to Kyle Connor is actually an example of that. That is our Net Zero series, our battery integrated, DC fast charger, where he's able to install that on level 2 infrastructure and still provide, up to 200 kilowatt output to vehicles, 2 at a time, on an ACS or CCS or some combination thereof. We provided that to him because we feel that the space really needs to understand that this is possible and that there are more options than paying a ton of money to the utility and waiting a ton of time to get this done. And we're ready and rocking with deploying that to customers today and have been doing it globally since 2020.
So with that, I mean, have there been kind of the change to the NACS or J3400, whatever we want to call it now, from CCS? Have there been any kind of surprise learnings, or I mean, is it other than just switching over and getting a different supply chain for the plug? Has it really been pretty straightforward? Or I feel like there's probably got to be more to the story as far as maybe new discoveries or challenges by just going to a different plug.
There certainly are, right? Supply chain was the first challenge we had to overcome. And, and full disclosure, I'm no engineer. I simply play one on television. But in talking to my team as we started the implementation of that connector, we wanted to make sure that it did work. And the first thing that we found out is when you plugged in back then, it doesn't happen now, but when you plugged in a Tesla, in 2022, into an NACS charger that was typically a CCS charger, not made by Tesla, right. It only charged Teslas that had CCS communication chips in them, right? Because we didn't have the language. Nobody in the space had the communication language or the protocols to speak to these older Teslas that were designed exclusively for the supercharger network. So when some of our customers in 2016, Model S's would come and plug in and their cars wouldn't recognize the charger, for a little while, we're scratching our heads. Couldn't quite figure out why, because everything we rented from Hertz and some of our personal cars would plug in and charge right away. These were all 2023 vehicles, 2022 vehicles. And then we started to piece it together. And that's why it's so important as an OEM to go through these interoperability tests with all manners of vehicles and all years of vehicles, and not just the ones that are on the market today or the ones that will be released tomorrow, so that we catch those things and don't have frustrated customers at the plug.
For sure. With are you seeing with a lot of these chargers that have kind of the battery backup system allowing for level 2 installation locations, is that becoming like a majority, or is what there's definitely a need for it. I'm just kind of curious if this is like really opening up like 25% greater, or is it like all of a sudden this is like a lot of people like, oh, this now makes way more sense for me. The unit itself might be more expensive, but
Right.
the uptime and everything else really makes it a much more straightforward answer.
It definitely depends on the use case, right?
Yeah.
I think if you are a charge point operator, a public charge point operator, trying to bring this infrastructure to somewhere where you otherwise just can't do it, battery integrated solutions are the right call. If you are someone who has an excellent location that has tons of power available from the utility, we make other products that I think would probably be a better fit if you plan to turn over 25 or 30 cars a day through 2 units. It's tough for a battery to keep up unless that battery is several megawatts large. So we do make products like our C7 that is a direct 480 connection. It's a 400 kilowatt liquid cooled, simultaneous charging unit with dynamic load balancing, all the fun words that you want to use in EV charging.
Nice.
That is your unit. If you really want to just sell as much energy as quickly as possible and you have the power to do it, more power to you. We have products for that. Many great companies in the space have products for that. What differentiates us is if you don't have that amount of power and you still want to do DC fast charging, you're basically required to use a Net Zero Series product, right, or some other battery integrated solution. And we figured if you're going to go as far as to include a battery with the charger to make it easier to install, you might as well make that charger and that battery bidirectional. It should have a direct solar input, DC to DC, like ours does, so that you don't lose any energy converting it from DC to AC and then back to DC to use it to charge cars. This is the most efficient way for you to not only offset your need from the grid, but in theory, if you had enough solar and enough time in between cars, you could be totally grid free, right? And provide energy that you didn't pay per kilowatt hour for. And instead, you were able to generate that on site and distribute it to cars. That's the best case scenario from a microgrid perspective.
For sure. I mean, yeah, that's like about as ideal of a situation as it gets for that use case. Yeah. With like obviously the Inflation Reduction Act, I always keep calling it the IRA, so I have to remember sometimes what it. How have you seen that kind of impact? Obviously, before that, there were subsidies for chargers, there were subsidies for solar and stuff, but it seems like part of the goal was hopefully to also make it so these could be packaged things together to kind of get a lot more of these products not only just implemented, but implemented as a package thing instead of maybe having to do multiple phases of the installation. Are you seeing that as kind of an outcome of this, or are you also maybe just, is it just word of mouth? This is just something more people are hearing about, so they're kind of coming to you naturally.
Sure. I believe the IRA has had a great impact on battery integrated technologies. And the reason for that is typically with NEVI funding or BABA compliance, you're looking at some portion of just the chargers that will be reimbursed, or in some cases, if you win a NEVI project, it could be the whole project, but you have some large number that you must contribute to that. When you add a battery, the IRA allows for you to take a tax credit of 30% of the entire project. And if you're using battery integrated project or solutions, that number can be pretty large. It could be $1 million in hardware. That $300,000 kind of off the top, you get to throw to the bottom line as a tax credit, which is tradable, or a rebate of some sort if you're a tax-free entity. And that dramatically brings down the CapEx of a project. So you have the batteries, you brought down the CapEx, and now you can use the batteries to peak shave, right, and pay less for your energy, or you install solar and can maybe even circumvent it entirely in certain use cases. Now you're going to be much more profitable over time as you sell energy to cars that you either don't have to pay for, or you can subsidize dramatically by taking during super off peak. I think that's the most important impact that we've seen, is just CapEx to the project itself. For sure. Because like I talked about, most investors are pretty wary of the EV charging space because of how crowded it is at the moment and how long it takes to ROI. When you start to add batteries and then you add a large tax credit to that, you get way more competitive much more quickly for the long term.
Now, do you know if it is just batteries, or is it if the project has batteries or solar, technically it can count for the 30%?
So I think you just need batteries to get to the 30%, right?
Oh, gotcha.
And again, I am no expert in the tax code, but you just need batteries to get to the 30%. And if you do have solar, there are additional drivers to help get you to like the 40% range. If you have generation and storage on site, we've seen as much as 40% of a project get funded. And that's
Yeah,
not
no,
something you need to try and win, right? You can just send in your details to the IRA and say this
right.
qualifies, and you earn that money.
That is kind of the crazy part. And I've always been. I realize there's additional costs with it, but like I've always been such a big proponent of parking lot solar,
Sure.
especially when it's. I get it, like if the parking lot's already there, but like there's so many of these projects where they're building a whole new facility and then parking in. If it's going to be all new anyway, it adds a bit of cost, but the delta is so much less if you just plan it all at once.
Agreed.
And then you can start unlocking so many cool, obviously longer term values with the solar, but especially with then even if you want to just do that first and then come back for
Right.
like phase two with the charging and other things, it just seems. I'm kind of curious. Has it mostly been price, or have there been any other kind of maybe technical challenges you've seen with the solar implementations lately with EV charging?
I think it's mostly price has been
Yeah,
the challenge, right? That's the toughest thing for people who invest in EV charging to overcome because it requires a little bit of faith, right? This
for
is an
sure.
asset class that has yet to kind of shake itself out as reliable. And we're starting to see the reports from EVgo, Electrify America, even Blink. These companies are up nearly 100% year over year in revenues. And that number doesn't go down next year, right? So now that they've started to see the adoption rate get where we need it to be to see that growth continue, it's more about how do we optimize every site that we've got and adding solar, adding batteries, adding technologies that work on 208. Like we make a charger that's a
Yeah.
direct 208 connection so that you don't need to bring in 480 new power in some properties. These are things that help just incrementally increase the profitability of a site. And I firmly believe that once EV charging gets to the point where it is investable by all the largest entities that do this type of infrastructure investing, you will see so much of it that it will provide that consumer confidence that we need to get to the next tier of EV adoption.
When when you talk about someone who's kind of on the edge or like looking to go and become one of these people that wants to invest in it, how are they? What is, in your experience, like, how do they come to you? Is it like, I'm curious about this, or I'm looking to do X thing, and since I'm building a building, I'm going to throw in EV charging, or I heard about these tax credits in the IRA. Can you help me there? I'm just kind of generally curious about, in your experience, if there is kind of like a ideal customer that comes to you fairly regularly with just like, yeah, I'm looking to do X, and can you help me get to this end product?
Yeah, I think our most common customer archetypes, there's three of them, right? You've got the folks who have fleets that have electrified and they're looking for a more effective way to charge their vehicles. Sometimes that's level 2 if their fleets have significant periods of downtime or overnight, etc. Whereas if you do have like a black car service that we service in Vegas, their vehicles are in service 24/7 and they're all
Yeah.
electric. So we had to provide a solution for them that kept them going, with DC fast charging in their garage where they could not get more power from Nevada Energy. So we had to
Interesting.
make do with what we had, and that dynamic load balancing is a good solution for them. The reason they found us is they went to Nevada Energy to request more power for a typical DCFC install, and they couldn't get it. So then they started looking at alternatives. Well, what can I do with the power that I've got? And XCharge provides solutions to do that. And then the third type is, the property owners or the charge point operator who wants to take advantage of the EV revolution and start to provide this infrastructure sort of as a service, and be the broker in the middle. Those folks usually find their way to us through trade shows or through word of mouth, or they went to go and install a charger and realized how long the lead time for a transformer was. So now they're backpedaling, trying to figure out what the solution is that doesn't require 2000 kVA. And, that's where XCharge comes in to fill that gap.
Interesting. Yeah, one of the things you meant, and I'm kind of surprised we haven't heard more interest in kind of that. I haven't been really able to come up with the right name to describe it, but essentially commercial EV usage. Like, all the headlines we saw kind of in the news in the winter, like in Chicago, with all these EV chargers are overwhelmed and stuff. Well, majority of it was just understandably, like usually Uber drivers or others that needed kind of that commercial use.
Yep.
And you look at the traditional like combustion engine gas industry, and you go up and down anywhere on the West Coast, you'll see the Pacific commercial fueling gas stations that are specifically for either a town car service or large trucks. And so it kind of inherently keeps the different traffic flows when someone goes to refuel. And there just hasn't been quite that yet, it seems like, for EVs. it just seems like everyone has to go to the local supercharger, whichever charger is closest to them, instead of like having that distinction of this is a private one that X company has just for theirs, or it is whether it's X charger, some business that just sells only or charges only for commercial use EVs. And I'm curious. That's great to hear that someone has done that, but is that becoming more of a thing, or have you seen anything kind of larger scale than that, instead of it being like a one-off business, or someone there being the business case for someone going to say, I'm going to be the Pacific commercial EV charger along the West Coast for Uber drivers or whoever?
Sure. There are a couple of companies that do it now. And, using an example without naming any company specifically, in the San Diego area, the airport has electrified its people movers. And those are in operation, 20 hours a day until the quiet hours in San Diego. And they either leased or bought up a large portion of land adjacent to the airport, and then they put in a ton of DC fast chargers with a new power request from SDG&E. And those chargers are specifically for these people movers. They're for the electrified taxi fleets to try and keep them off of the very constrained local infrastructure from the EVGOs, the Electrify Americas, the Tesla superchargers. And they're not designed to handle these large buses. They don't have pull-through stalls. It's very inconvenient when someone's going to block 3 stalls of charging so that they can get their truck recharged. Now, you can't really blame the truck driver. He's working with what he's got, right? So, in my opinion, that just needs to be a space that's more mindfully attacked by the folks that provide this level of infrastructure as a service or as a business. Those who provide charge point operation as a professional business, they know that there's a specific customer type that they're after. And if you're after just public charging, you pick the right parking lots for that. You pick the commercial lots that have the Vons, the Starbucks, those sorts of convenience features and amenities in them. And if you're charging fleet vehicles, you're talking to your end customer first and saying, where would we solve a need for you? And in this case of the San Diego airport, it has to be within a half mile of where these things are typically en route. And they did find that piece of property, and then they fenced it off and added RFID cards for gates so that only they could access it. And that solves both problems. You're not congesting the public infrastructure, and the people who need it on a commercial side are able to get to that quickly without running into challenges in stall design and how to turn their vehicles around. Right. I've seen lots of medium class vehicles charging at Electrify Americas because it's all they had, and they take up half of all the stalls, and it's really inconvenient, and they have 200 kilowatt hour batteries that take forever to recharge to begin with. So it's good to see that the industry start to differentiate itself in those various use cases and not just say all chargers are good chargers in the right place.
For sure. And I figure that is happening. I just hadn't heard too much. And there are obviously, usually it's kind of like city or county level that might have like a bunch of electric buses. They'll have their own depot or something. But then you kind of start getting into that medium use case where you're getting the negative headlines that we saw with like a lot of Uber drivers, and just trying to find out what that right balance is. So that's great to hear that it's probably not going to happen overnight, but it is being solved. Which
it is, and I think it's important because there are certain types of public services. Let's take police departments, for example. You typically don't pull up to a gas pump and see several cop cars refueling there, right? It's very rare when they do that, and it's on a need-by-need basis. They have gas pumps at their depots. As these vehicles electrify, because they're going to the vehicles, or the shops as they call them, go from shift to shift, right? They don't really get a whole lot of downtime, and the police department is open 24/7. So they're starting to look at DC fast charging infrastructure as well, because level 2 doesn't quite do it for them when those vehicles need to be back out on the road in half an hour. So giving them their own DC fast chargers behind the fence at these police departments is something that we're contacted about quite a bit, actually, to help make that happen. And, that's going to provide the confidence not only to the department, right, but to the officers themselves, right, and having the ability to use these vehicles for all the various use cases that they need every day to keep our communities safe.
Yeah, I'm kind of curious with that kind of use case where it's a pretty frequent DC fast charge. Is there, and this is obviously probably kind of model specific, but I'm just kind of curious, is there like a speed you've been, or like a charger you recommend, maybe not all the way at the 200 kilowatts, or maybe it's just site specific, like maybe 50 or 100 is good enough for these? Or
I think it depends on I mean, most departments have very good data about how long their vehicles will sit in soak time, we call it.
Gotcha.
So it typically requires almost a consultation from a charging company
Yeah.
to look at your fleet. How many are you electrifying right now? Okay, well, here's the plan. Because if you want to go with 16 stalls of DC fast charging at a police department now, no way you've got the infrastructure for that. So you would start with 2 to 4 stalls, and then you would say, as you start to get to 20%, 40%, 70% of their fleet is electric, this is how we would expand upon that, and use some dynamic load balancing. Maybe all the chargers are capable of 200, 300 kilowatt, but when they're all plugged in, you can ramp that down substantially to 50 to 100 kW each. And that way, you're not putting such a strain on the resources that you've got in order to make this happen in the first place.
Yeah, I mean, that's definitely been an interesting topic, is for so long people said, oh, DC fast charging ruins the battery over the life of the battery. And it's like, the more data we've seen of it, it surprisingly is pretty minimal, if any, depending on the it's like, since most are now thermally managed systems in EVs, that's really gotten rid of it. So you can see these I think probably the most common is just because of the volume of this Teslas that were used as like Ubers and stuff that were pretty much exclusively DC fast charged. And it's like, maybe it's a couple percent extra degradation, if that, but the number is so small, it's so, you almost can't even tie it to DC. It could just be that battery. It could have been some other use case, or like it was in the cold a lot more or something, which is really cool to see that that's kind of what it's turned out to be. So it does allow for these commercial applications where, while level 2 is a great thing, it just might not be practical for some use cases. So it's turned out that if you need an EV, more likely than not, there's a way to make it realistic for your business.
Yeah, I think in the industry, those of us have been in a while and know quite a bit about the battery technology in the vehicles. We are willing to say, I'll go out on a limb here to say that DC fast charging is not inherently harmful to your battery, at least not to a measurable degree that over the life of ownership of that vehicle, you will notice in your day-to-day. I think there's several studies on some of these 2014 through 2016 Tesla Model S's that were primarily DC fast charged, and you're seeing degradation of sub 10% over the course of a decade. That, I think that would be what we consider an acceptable loss, whereas with an internal combustion engine over the course of a decade, the wear and tear on the motor itself usually will be more significant than that of, the electric vehicle equivalent. And, the cost to replace a motor is probably about the equivalent of the cost to replace a battery these days. I've had several less than ideal ICE vehicles over the years that I've liked to own and drive it until it explodes. And when they do explode, I have never gone through the effort of replacing the engine. Turns out I've always just replaced the car.
Right. Well, you bring up a really great point that I don't think a lot of people realize is, yes, EVs are warranted to like have a degradation level and stuff like that. And then within that degradation level, like we're talking about, the impact of DC fast charging is like potentially a small percent of that. It's even hard to tell to what extent. But combustion engine vehicles lose power over time as well. And I don't think enough people fully appreciate that. One of my favorite like Top Gear things they did was they all went out and got like, the goal was to get like I think it had to be at least 20 years old or something, some sort of random European car, and they had to find out who still had the most power of what the car came with. And I don't think any of them crossed even the 50% mark.
Yeah, not even close.
Right, which is such a wild thing that I just don't think most people fully appreciate. Even if you are a mechanic, I think I even had this discussion with a couple of my mechanic buddies, and I have to remind them, don't get me wrong, I love a good V8 here and there, but it's not going to. It also deteriorates. It's not like it is the same. There's a reason you have a break-in period, and there's also a reason you have to rebuild the engine and replace them eventually too. So
there's a reason they make high mileage motor oil,
Exactly.
And when these vehicles get older,
trying to milk them out as much as possible.
Yeah, they get substantially less fuel efficient in the process too. So it's not even just less reliable or less power, but you're literally less fuel efficient. So I don't see how that's any different than less efficient from a battery perspective.
For sure. Well, I think we've talked a lot on that, the commercial. But no, this is super fascinating because it's been one I've been wondering quite a bit about. And so I think you are in probably as deep in the EV charging realm as it can be. And there has been a lot of kind of shakeout in this past year, it seems like. And I think personally, it's unfortunate, but not kind of surprising. I feel like there's just been a lot in the space that had kind of been built up, and maybe good or bad, there have been a lot of people kind of rushing into, and like we had been talking about, just with any technology, there kind of is that rush, kind of fallout, and then what is left is what kind of grows to become a long-term and sustainable industry. And so I'm kind of curious with what you've seen, because there's so many negative headlines, has there been kind of, people are now kind of taking a step back because they're, I don't know if these EVs things are going to be forever, or is that more, instead of like a commercial mindset, that's more like maybe a biased personal one-off mindset sort of experience, if that makes sense?
Yeah, I think I know exactly what you're saying, and I think most people, I'd be willing to say that the overwhelming majority of people who are even remotely familiar with the space do not believe that EVs are a fad. I don't think that this is something that's kind of passing in the wind. I think that these vehicles are coming. I think people will adopt them when they get to the price point that makes it financially reasonable for their household. And they already provide numerous benefits from a maintenance perspective, from a safety and reliability perspective, and a technology perspective. The cars are here to stay, which means the infrastructure's got to get built. So when you see some of these headlines and the things that Tesla does and some of these other companies where they start to fold due to insolvency, consolidation in this space was necessary. There are some very sharp people in the space, Lauren McDonald being one of them, that talk about this ad nauseum. So I'm not going to rehash their points, but I think consolidation was necessary. And I think that those of us, and I know many obviously in the space, who are already after the deployment of this hardware at mass, some of these news headlines and some of these players kind of pulling out of the space full speed have only incented us to go faster, to do more. I've seen more investors come into the space over the last 2 weeks than I had seen in the last 2 years, because they believe that a large gap is being left by people like Tesla slowing down their deployment plans from a rollout perspective. And I believe that Tesla will support their network very well. They're in first for a reason, and it's not close. But them doing anything other than stepping on the rest of our necks gives everybody else an opportunity to grow, and you're going to start to see this democratize a little bit through other companies who are coming into the space with fresh capital and new perspectives.
No, that's great to hear, and I kind of agree with you. I think in a lot of ways people were kind of freaking out because of the Tesla news, and I think, I don't know, I remember there's always something people are freaking about when it comes to Tesla, and I think they'll only ever be in trouble if there isn't something good or bad, done by themselves or not, that people are freaking out about. If it just becomes, it's Tesla doing another thing and they're not a news cycle, then that's probably when Tesla as a company needs to be worried, because they're no longer the Apple or the special kind of shiny thing that they have going for their space. But even then, they're saying they're hiring some of these people back, and they had the massive layoffs like a year or two ago in the sales department. No one was like, how are they ever going to sell cars? And obviously they survived. And I kind of think there's an element where you kind of have to separate Tesla and leave them out from it. But at the same time, it is just the also element of like, that's kind of the short-term mindset versus like kind of taking the temperature of like one random day. And you can do that for pretty much any industry. And there's going to be a really bad temperature or something you take for that day, because that was the big thing that happened that week. But looking at it long-term, it just seems like there's still so much potential. And I do agree with it. I think maybe it slowed down some of the EV adoption by car buyers, but it's so fascinating to me at the same time, because so many of the people who are saying it slowed down 36 months ago would have said, EVs are never going to get to 10%. And then like 12 to 18 months ago, they're like, I think it's going to get to like almost 50% within like a year. And now they're like, well, it's slowing down. Maybe it'll be 30%. And so it's like, it's still like taking a step back, and sure, it's slowing down, but I really do think it's a short-term thing. And it still is really interesting and surprising to me, just even though people are like kind of taking a step back, some of these people have been very conservative and have a lot of industry experience in the automotive space. Their projections still aren't, even I would say more of the doomsday numbers aren't even as bad as those numbers they used to say, or others of a similar mindset only said a couple of years ago. And you still look at, while there's been some slowing down in the Chinese EV market, I don't think it's like slowing down so much as it's almost what we've seen in the North American headlines about the EV charging space, where it's they're slowing down almost for consolidation, not and some market stuff. But it seems like majority is that is where they are going, and then some. And the EVs they have for sale in that space are in a lot of ways light years ahead of especially when it comes like you look at the charging capabilities of some of these,
Right.
And what is even on the market in here or Europe. I'm curious if, with like some of the numbers that have been mentioned, because I mean, some of these Chinese companies are claiming that they have cars now that aren't much bigger battery pack wise than like, let's say 100 to 120 kilowatts that can do anywhere from 300 to, which isn't crazy, but like almost 500 kilowatts charging.
Right.
And sometimes some of these cars are closer to like 75 kilowatt hours. So it's like crazy C numbers that we haven't really ever seen before as far as charge rates. I'm curious if there's been any, does that ever come up in conversations when building a site for like future proofing, or how to look at maybe 200 kilowatts is fast now, but a couple of years ago, 150 kilowatts would have been mind blowing. And now it's kind of like at best table stakes.
I think you're absolutely right. A lot of the discussion that we have now with customers is, how do I get infrastructure in now that can be upgraded later, right? And when you talk about the difference in infrastructure, just for context, right, for a lot of the listeners that may not be in the space every single day, the difference between what's required for a 150 kilowatt charger, which is considered average these days, and a 400 kilowatt charger is more than double, right, of the amount of grid connection. A 400 kilowatt charger is, with the headroom for NEC, you're looking at 600 amps of power for a single unit. So if you want 10 of those units on site for any reason, that's 6 megawatts worth of power and then some. The infrastructure to do that is unbelievably cost prohibitive. So while you do want to future-proof where possible, the way you do that is by larger conduit in the ground so that you can pull more wire when you do get to that stage of upgrade 2, 3, 4, 5 years from now. But I think the vehicle market is a good way to kind of use that as a predictor for where you need to be in the nearby future. Most EV charging infrastructure is good for about 10 years of service life before it needs a refresh or a replacement. And when you look at a vehicle, using the Porsche Taycan as an example, these vehicles aren't charging at 500 kilowatt, 600 kilowatt right now, right? And when you buy one, I bet you want to keep it for 6 years.
Price aside, I think that has become my new like dream car. Just obviously the Porsche brand, it's just unto itself and the driving side of it, but it's like the charging and road tripping capability of that thing is at least what we have for sale in North America, pretty much second to none right now.
Absolutely. And I don't see that one becoming not relevant from a charge speed, over the next decade. I would be plenty happy to own one now, and I think I've never met anyone who looked at a Porsche and said, I really don't like the look of that vehicle. Never heard it in my entire life.
I will say, and maybe this is just me, I thought that the what were those? The Panameras were pretty ugly.
The Panamera,
but they were so fast. They were so fast that you didn't ever get that good of a chance to look at it. So that solved its own problem. But
it was polarized.
I may be biased. That was the only thing that they ever made I was never a big fan of. But everyone I've talked to who's had the chance to really like drive one, enjoy one, and the interior just swears by them.
Tell you what, though, you pull up in a Panamera to a restaurant, and somehow the valet always leaves you out front. It does. Yeah.
And don't get me wrong, it's still a nice car. It's just personal taste. That was just one aesthetically I thought was a bit of a miss.
Yeah.
But I think the Taycan, which was almost like the second take of that style of car, 11 out of 10.
Absolutely.
But yeah, I guess that is kind of interesting. Like, do you see, while it's sometimes cost prohibitive on the site side, have you seen costs? And some of this obviously is still kind of like almost a supply chain from COVID hangover. Do you see there becoming scale and cost associated with larger charging locations on the utility side coming down at all? Or is that still kind of a ways out, you think?
That's the dream, Chase.
Okay.
I don't think we're there right now. And I think that there are some programs for, Southern California utilities where you can, like Southern California Edison's Rule 21, where they will pay for all the behind the meter infrastructure. That's great. That's well and good. But when they pay for it, you're sitting in line waiting for them to bring it. And that could be 3 years. It has been 3 years on many projects that I'm aware of now. I don't think that we're to the point where we have, gotten ahead of the infrastructure deployment curve, just because outside of EV charging, there are many other industries that are requiring substantially more power now. Data centers is a big part of that.
Yeah.
The amount of energy a data center uses is staggering, and I'm not going to pretend that I'm an expert and quote it, but they require the same infrastructure, the same kinds of switchgear, the same kinds of transformers, and then some.
Yeah.
So those projects to the utility are very important because they're part of the IoT, the Internet of Things, right, in order to get our communities moving more efficiently and more intelligently. But they also are a much larger customer of the utility than the donut store and the DC fast chargers there, right? So the utility has got to be mindful of its constituents' funding and its resources as to what provides more revenue for the utility that will then provide them more opportunity to provide power to everybody.
Right. Yeah, that's kind of interesting. Living here in Central Oregon, I'm trying to think of how many we have. We have Google, Apple.
Yep.
Who else? Oh, Facebook.
Sure.
Surprised, like all of the big tech companies have opened up data centers about like 20 miles east of here, just due to the cheap power. And each of them pretty much have had the ability for them to work with Pacific Power and BPA and just have their own. And you're totally right. It's a fascinating dynamic where it's like they only have maybe a couple locations across the U.S. that need this power, but the scale of it is so significant that it buys up not only just so much of their own resources with the utilities, but also the custom lines and power lines and everything that has to be built to just go to these kind of random locations and the upgrades associated with it. That I get the business case and some of the other pros of doing that. But it's like the scale is a few very, very, very large sites versus with what you're kind of dealing with. It's like maybe best case, some medium-sized cases, but a lot of them. Right. And I know that's even just a thing that, especially with solar and people who are trying to do some of these smaller installations, like feeding into the grid, trying to fight for the bandwidth almost to get on there. So
absolutely.
Yeah. That could be unto itself its own podcast.
That's a whole episode we would get into right there, especially
complaining or trying to discover ways how it can be improved. Maybe let's put it that way to be more positive about it. But I realize we're also kind of coming up on the top of the hour here of our conversation, and I just want to say thank you so much, Lew, for coming back on. Hoping to have you again on soon.
Absolutely.
And it's wild to me how many things have happened in the last few months since we last spoke. So I'm sure we'll have you on soon again to talk about hopefully the all good new things that have changed.
Exactly.
Until next time.
Well, the pleasure's been all mine, Chase. It's awesome to be on Grid Connections once again. I really enjoy the conversation and the breadth of your knowledge on all these various topics, and you let me nerd out a little bit with you for an hour. So I appreciate the time. I mean, X-Charge appreciates the time, and if you need anything from me, you know where to find me. Looking forward to the next one.
Thanks, Lew. Have a good one.
You too.
Thank you for tuning in to this episode of the Grid Connections podcast. We hope you enjoyed our conversation with Lew Cox, the Senior Director of Business Development at X-Charge North America. Lew's insights into microgrids, the latest EV chargers, and the evolving state of the EV industry have provided us with a deeper understanding of the innovation shaping our energy future. Stay connected with us for more expert discussions and updates on the ever-charging landscape of electric mobility. Until next time, keep exploring and stay charged.